This is the third method to expand brackets, and it is definitely the preferred method, so use this whenever possible, please. We will go through the steps to do this, and we'll actually use example 10 to do it, which is y equals 2x minus 3 and x plus 4. You'll notice that this is exactly the same example as what we've used previously in examples 8 and 9, so we should be getting out the same answer. So step 1 is to split the first bracket into the pronumeral and the constant, and then just put a gap in between. So here, for example, we have y equals ax, then a gap, and then the plus b. So for what we're doing here, we're going to have that 2x and minus 3, and we split it into two separate terms with a gap in between. So that's step 1 done. So take your first bracket and split it into the two terms. Step 2 says, well, write the second bracket next to the pronumeral and next to the constant. So we have a pronumeral of 2x, we write the bracket x plus 4 next to it. We have a constant of negative 3, and we write the bracket x plus 4 next to it. We are in fact actually multiplying 2x by this bracket, and then multiplying negative 3 by this bracket. So we're expanding, or we're using this distributive property to expand. Step 3 says, well, let's just expand each bracket. So we go 2x times x, which gives us 2x squared, 2x times 4 to give 8x, negative 3 times x to give negative 3x, and negative 3 times 4 to give negative 12. Step 4, last step, is just to simplify that. So again, 8x minus 3x gives us 5x. So we can simplify this down to give y equals 2x squared plus 5x minus 12. That's our end answer, so we box it. So this is our preferred method, the distributive property. It is the most important one that you actually understand, as this is the one we will use more often than not in the future. Lastly, we've got some set rules. So the set rules are basically, I suppose, shortcuts to expanding. So you can always expand using the distributive property or either of the other two properties, but there are shortcuts in order to do it. So we've got 3 different cases. We have the difference of 2 squares and then 2 different perfect squares. So difference of 2 squares is where your first and your last term in the brackets are the same, but your sign in the middle changes. So instead of a plus here, we'll have a minus. So a plus b and a minus b. If you have this scenario, then when you expand it, you actually find that your middle term will cancel out. So you won't have, for instance, this 5x term in here. Instead, you'll have a times a squared, and then b times b squared with a minus in the between. So this is a difference of 2 squares, and it's a set rule. You also have 2 cases of the perfect squares. So perfect squares is basically where you either plus or minus 2 values, and then you square the entire bracket. So in fact, it looks like we've got 1 bracket here, but we do have 2, because what we can do is go, well, anything squared is itself times itself. So this is the same as having a bracket, a plus b, times another bracket of a plus b. When you expand this, it will always work such that you'll have an a squared term, a b squared term, and the middle is 2 times a times b. Now the only difference between having a plus here and a minus here is that we'll have a plus and a minus here. So you'll either have to plus the b squared or minus the b squared. So just be aware of that. So these are some set rules. It will be expected at some point that you will recognize them. So please start to look for these patterns.